Hi, today I built something called as the LabLens. So generally, if you are looking for some sort of a test like thyroid profile test, what we tend to do is we open some leading for the lab test providers. We open a website, we select the location like Bangalore. Then again, we search for the thyroid profile test. We load it. We see the price. We also see what are all the some key details in this. Similarly, here also, like if there's a website, sometimes a pop-up comes, you select it out, then you again search for thyroid profile. You pick something which is relevant. Again, you compare the price here. Similarly, here as well, thyroid profile, total blood. So here also it gives this. Sometimes if you will compare all these prices and still if you want something more, you tend to do like thyroid profile in thyroid profile test in Kormangla. I'm sure each of you have different ways of searching in the maps, and it lists down the all the labs near you, and then you pick based on the review rating and go for it, compare the price. So that's what this lab lens automates. So here the the websites are configured as the by the app, and the AI agent analyzes each website. It doesn't do a web scraping. It goes to each site. It kind of mimics the human behavior of all the clicks and extracting the details, sending it to the LLM, and then taking a good decision at last. So in this case here, so it has gone to the Metropolis, 1MG, the Practo, and finally Google Maps. And it has provided a comparison, like what we saw there. Each provider, what is the price, what are the offerings, etc. And also the nearby labs. This is just a start here, the Google Maps results and its rating. Maybe ambitiously, as a next step, we can dig deeper into each of them, go to their website and extract as well. So here if you see here, the replay tab, so the planner fans out to four sources. We'll walk through what actually happened at each one. So if you see here, so every source starts at layer one, a plain HTTP fetch. There's no browser, no LLM, and it just does a HTTP fetch. Practo's layer one hit an Akamai security wall because they have strong anti-bot detection, etc. So we moved on to the layer two. So layer two, a real Chromium browser is spun up internally. That it's like a headless browser. It reads the page's accessibility tree, a number list of every button, input, link, and sends that text list to a Lang LLM, which decides what to click. And then there are three turns waiting for the React to assist. Like then on turn four, so on turn four, Pacto, one more. Yeah. So on the turn four, the LLM read element six showing thyroid profile rupees 420 and called done immediately without going into further details. So this took, I think, about 56 seconds to complete. Similarly, the 1mg, here it says it's failed, but it is progressed to some decent extent. Uh, so it all, if you see here, let me open this in a new tab. So after going through several turns, it's finally reached that, okay, Bangalore, and it has carried out that test. I mean the search, and it has clicked that, and finally it has come here. So this is how it has detected it as 439. But I think maybe this 1mg hit some sort of a rate limit issue. Yeah. Similarly, the Google Maps, it's a layer 3 vision. If you see here, yeah, it's a layer 3. So in, yeah. So here, layer three, because it's Google Maps is like a canvas interface. The browser provided accessibility tree as a, is almost nothing useful. So we skip to layer three, the same browser, but now it takes a full screenshot and it uses Pillow to draw to kind of do the annotations. So these annotated image goes into a Vision LLM, which reads the lab panel directly from the pixels. So that's how it's able to list down, okay, this is the first provider, this is the second, third, fourth, so on. Okay. And here, if you see the Metropolis, so the layer 2B opened the browser, the so the layer 2B opened the browser, the LLM dismissed a pop-up because generally we see that there's a pop-up appearing in the site, and then the city picker appeared as fixed overlay that isn't captured in the accessibility tree. So the agent can't see it. So after one turn cap hit the that's honest output, the cascade reports what it found and moves on. So it was not a very useful result. So in the comparison here, yeah, as I said, like it provides this price comparison and any other offers, anything which is there for you to visualize. And similarly here inside, it summarizes the key findings from each of the website that it has found. One critical thing I want to show here is yeah. So the cost ledger here, so it says like there were 15 turns across the sources and about 31,000 tokens in total, and took about 9 minutes to carry out this search. So most of time went in like waiting for the JS to render, or if there is a human validation where it says wait for 60 seconds, etc. And yeah, I've used all free providers only in round robin fashion, like GitHub, NVIDIA, Cerebras, local Ollama, multiple things, and it internally fault tolerant, it's fault tolerated. So that's why the cost is zero here. And the Git Cerebras and GitHub handle the text calls. Ollama handles the vision locally. So if you see here, this is my repo, and feel free to check out. I've explained about each of these providers, what layer it picked. It went through layer one, then two A, two B, etc. And then more details here on what it found in each of the websites. Yeah. Yeah, this still early stages. There's a lot more to be explored here, but yeah, this is a good start that I would bank upon. Thank you.